In this tutorial, I'm going to be walking you through the advanced sketching techniques. The key content includes advanced constraints such as tangent, symmetry, angles, distances, and dimensional constraints using expressions how to make your design more scalable. Also about the construction geometry and external references. And last but not least, the common errors that most of beginners would do and how to fix them, along with robust tips for sketching. The advanced sketching techniques go beyond the basics and it gives more control over the 2D sketch. And these constraints includes the tangent constraint, which forces the curve, like in a circle or arc, to be tangent to another curve or line. And the next time we have symmetry constraint. It makes selected elements mirror around a center line or an axis. We could say it could be X or Y axis. And the angle constraint, we set specific angles between two lines or edges and useful for inclined parts and sloped surfaces. And the distance or the length constraint, and it helps you control the exact distance between 2 points, and the radius and the diameter. And it sets the size of an arc or circle to fixed radius or diameter. And the distance between 2 points, it ensures the points are separated by a fixed value. And the other basic constraints are vertical, horizontal, parallel, perpendicular, and the coincident. So we'll be using most of these advanced sketching techniques to make a demonstration at the end of this video. We have also created a learning resource for this tutorial series, which you can find it in the description. And I encourage you to refer the document for an enhanced understanding of what you will be learning in this part. What you're seeing on the screen right now is a yoke link. So I'm going to show you how to design this with proper advanced constraints. So we're first going to work on the 2D sketch. And we're gonna path the sketch along the z-axis, and we're going to gradually work on the refinement aspect. Alright, first I'm going to create a new file. And create a body and a sketch. I'm going to choose the XIVIX plane. I'm going to use the centered circle and take the intersection of these two axes as a center point and draw the circle outward. I'm going to draw another circle by applying the same process. And now we can add the constraint to these two circles. I'm going to use radius constraint. You can either click and F on your keyboard or just select it from the toolbar. Let's do 10 millimeters. This one is 20 millimeters in radius. So now we're going to use this polyline. Draw a horizontal line. Let's repeat the same process into this side. In a couple seconds I'm going to show you why I have not connected these lines against the circle. Now let's use the symmetric constraint to apply the symmetry. First you have to select these two vertices and then click on the axis about which you want to make the symmetry. And now I'm going to explain the reason why I did not connect these lines into the circle we drawn in the first place. It's all because of this tangent constraint. You can use this tangent constraint to force a line to have a connection or just press against a circle. You basically click the line and just click on the circle, and now it's perfectly tangent. I'm going to apply the same logic to the side. Now both sides are perfectly tangent to the circle. And here you can see they're not in a perfect level, so I'm going to use this. And there is the horizontal constraint. I'm going to click on both vertices here. Okay, now they're in the perfect level. So now you can see there are 6 degrees of freedoms, which means we have to ensure the proper constraints. I'm going to assign the dimensions. You can press on D key on your keyboard to enable the constraint, or you can simply choose it from the toolbar. You can see each on the constraint warnings are going down. As you can see, the shape has been compromised. That's because of the auto constraints. You just have to delete these, and we're going to manually apply them. Choose the vertical constraint. And apply them. Click on this line and also this line. Press on the equal. Equal is also a constraint. It's pretty much like you can use when you want to apply the equality. And you can use this trim tool to trim out these unwanted lines. And now I'm going to press D on the keyboard and apply this dimension to this line. Now you can see the sketch is fully constrained and turned into grain. Okay, let's close this. You can go to the front view to reorient the drawing. Click on the pad operation. And you can adjust the length. I'm going to do 30. No, 30 is good. And apply symmetric to plane. And now we have to cut another set of circles, so I'm gonna choose this surface and create a new sketch. And this is the external geometry. What it actually does is that it lets you connect your sketch to an existing sketch. Pretty much like the shared geometry from another sketch. So click on this and apply it onto this line. And again use the centered circle and draw the centered circle. Always remember that you have to always go back to the axis in order to reduce the number of under constraints. And again, I'm going to use the radius constraint and set the radius to 8 millimeters. I think 6 millimeters would be better. As you can see here, there's still a remaining under constraint. So we're going to use the dimension tool. Press D on your keyboard and use that external geometry as a reference and set their length to 6 millimeters. No, that's to about 12 millimeters. Okay, now it's fully constrained. Let's close it. And now you can use the pocket operation, and you can set this symmetric to plane and make it through all, so it cuts through the whole solid. And I'll click on OK. Okay, now we're going to work on the side profile of the yoke link. You have to select this surface and create a sketch. And once again, we're going to need the external geometry here. I'm going to bring it into this line. I'm going to use the centered circle again. We're going to set the radius to about 6 millimeters. And repeat the same process. Take the central line of the circle and the external geometry to apply the length. Now it's fully constrained. Click on close. You can use the pocket operation again. Click on symmetric to plane. And dimension to through all, the type. Now it's good to go. You can click on OK. Now the solid has all it needs perfectly. You can click on FV on your keyboard or Fit All in order to immediately reorient your model. Okay, let's talk about how to use expressions. So expressions are extremely important when it comes to the scalability of a sketch, because even though you have fully constrained a sketch, it does not always ensure the scalability of a model. Let me show you. So if you change the length of this line into 8 millimeters, just imagine the previous design is the original look of this yoke link. And now you can see it's no longer the original design for the yoke link. In other words, the solid has been compromised. I'm going to change the horizontal length into, let's do 55 millimeters. Now you can see the entire sketch now has been completely distorted. It's no longer how we have imagined the original design in the first place. So let's take a look at the solid. Even the pockets we created, even those are disappeared. Let's go back to the sketch. I'm going to show you how to get rid of these scalability distortions. And that's when we need the expressions. So expressions basically help you gain the total control over your sketch. Okay, first I'm going to rename the sketch. I'm going to name this link sketch. And right after that, you can see the pocket circles we created, which were disappeared as we changed the dimension of the solid. I also renamed it. Let's do the same for this pocket over here. and go to the sketch we did for the link. So I'm gonna choose this line because it's gonna be the driver for all the lines to contribute to the scalability of the design. So I'm going to rename it driver and as the main driver, and click OK, and just go back to it. You can basically think of the main driver as the master and other lines as the slaves, so the slaves will be served to the master on commands. Over here you can see this little icon. You click on it to open the expressions editor. You search for constraints and you can see it automatically shows the constraint that we defined. And you can see the result above it shows 40 millimeters, which is the current length of the driver. You can basically use any mathematical expressions you want. I'm going to use the multiplication and 0.5 because I need this line to be half the size of what main driver, the master line is. And now you cannot manually adjust the length of this line because now it's getting its command from its chief, the main driver. But if you change the main driver's length, it will be reflected in the slave line. Like this, now it's half the size of what the main driver is, which is 40 millimeters. Even though it has compromised the original look, that's because we have not assigned those expressions to the other lines. We're gonna get into it in a second. For now, I'm gonna set the original master value back to 40 millimeters and start working on this line. It's currently 20 millimeters. Just search constraint and main driver. So since the main driver is 40 millimeters, because in order to ensure the original design, I'm going to half the size of the main driver. So I'm going to multiply it by 0.5 and hit OK. And I'm going to click the radius of the circle and go to the expression icon, open the expressions editor, search for constraints and the main driver, and multiply it by 0.25 because that's how we get 10 millimeters for the circle, and click OK. I'm gonna do the same for this circle radius, and we click on this icon, open the expressions editor, open search constraints in the main driver, and multiply it by 0.5. That's how we get the 20 millimeters, which is the original radius we set for this circle. And now it's fully scalable. You can see if you change the length now into 80 millimeters, now it's fully scalable in design. I can close the sketch view. And you can see the circles we used the pocket operation, those are still disappeared. Let's go to the sketch. So we have to do a little bit of work around here. We have to this constraint. We're gonna establish a new constraint. Slide the circle along this axis and bring it down. And you can apply the distance 12 millimeters. Just click OK. Now you can see it has reflected as we need it. I'm going to do the same for the other circle. set the length to 12 millimeters. And I'm going to open the expressions editor for this circle. And once again, you have to repeat the same process we carried out for the other circles. Search for constraints, and then master, and hold on. What can be the reason that the sketch we created for master driver is not appearing? Well, that is because the master driver is from another sketch, because we did not use the same sketch to the entire design, and that is the reason why I renamed those sketches. So now we have to import that sketch into this sketch to have. Okay, now we search for link sketch because it has the original master driver, and now we can type constraints. And here we go, the main driver. And I'm going to multiply it by 0.15. That's how we're going to get 6 millimeters for this circle's radius. And click on OK. And we also have to apply the same expression to this length here. You search for the sketch, link sketch, go to constraints and search for main driver, and multiply by 0.3 and click OK. Can I close it? The same logic will be applied into this circle right here. Everything is all the same over the expressions editor. Go to link sketch, constraints, main driver. You do not necessarily have to search for the original sketch where you have defined the master driver, since we're already in the master driver, but it will not be throwing any errors. Okay, there we have our model. Now you can add the fillet. You can select any face you want. As you can see, the fillet has been applied. The current radius is 1 millimeter, so I'm gonna remove this face for now. I'm gonna select the edges. You can go to the wireframe mode. That'll make it much easier. Now we'll select these circles. You can see in the preview box all the selected lines are included. Okay, now we can adjust the radius. The fact that we use minimal numbers throughout our design, we have to reduce the radius down to minimal and click on OK. Here we go, all the fillets have been properly applied to the solid model. You can also change the color of this yoke link. Here you go to the appearance. You see some material properties. You can change the diffuse color. Click OK. And close it. You can see the color is reflected in our model. Now I'm going to reset the original value of the driver, which is 40 millimeters. And this is our completely scalable and fully constrained model. In this part, I'm going to show you some of the most common errors that the beginners usually do while designing and how to solve them in order to streamline the design process. As far as I can think of, the most probable cause for constraint errors is that having too many redundant constraints in your design. So I'm going to demonstrate it using the previous model we designed. As you can see in the screen, the sketch is now fully constrained. I'm going to use a symmetric constraint or equal constraint. I'm going to apply it to the both lines here. Now you can see in the solver message it shows a redundant constraint. The 18 is a redundant constraint, which is the equal constraint we applied. So that is a redundancy. Because it is already constrained, you have reconstrained it using another constraint. That's the literal meaning of what redundant constraints are. And next I'm going to use the parallel constraint and apply it to this. You can see now it's over constrained. You can see the following message says, please remove at least one of the following conflicting constraints. Let's go down. And now you know actually what constraint is conflicting the most. You can either deactivate it or delete it. So I'm gonna show you. For now, I'm gonna deactivate it. It says solver failed to converge. That means the 5 is not actually the one that conflicts. You go down again. You can also try deactivating it. It shows the same again. Solver is still failing to converge. You reactivate it. Try deactivating this. Deleted it. Perfect, now it's fully constrained. In general, those are the most common constraint errors you will face. I highly encourage you to constrain your sketch gradually and early in order to minimize these conflicts in the design. And most important thing that you must know is that you have to anchor the sketch into the origin, either X, Y, or Z plane that you're working on, because they are embedded into the original coordinate system, and the coordinate system is the engine behind all these geometric constraints and everything you do. So always be advised to anchor your sketch into the origin. and also use the symmetric constraint wherever it is possible. Instead of duplicating dimensions, that will help you streamline the design process because it dramatically reduces the constraint count, and as a result, it makes your sketch more clear and easy to modify picture at the same time. Now we have come to the end of our tutorial. In this tutorial, you'll learn how to work with the advanced constraints such as a tangent, symmetry, and also how to use expressions in order to make your design more scalable and responsive, and the most common errors and how to solve them, also tips to streamline your designing process. In the next tutorial, you'll learn about additive and subtractive features and how to use them in your design. So subscribe to our XIVIX University channel and turn on the notification bell so you'll be notified when we upload our new tutorials like this.